The purpose of this video is to go over some of the basic concepts involved with taking measurements using a ruler or a device very much like a ruler and the associated uncertainty. In this lab, you will be doing this semester both in person at home, in some of the at-home experiments, as well as using the Pivot Interactive's website. We're going to begin by measuring this red rectangle, and in order to do that, we need to position one end of it at a known value, in this case the 0, although because we have to use our eye to see where that position is, what we're going to find is that just as there is uncertainty with the actual measurement on the right-hand side, there is also uncertainty with how we position the object on the left-hand side. So I've positioned the object as shown, and I've aligned the ruler to it. And now if I look at this rectangle and the ruler, I would say that the measurement is something like 4.8 centimeters or 48 millimeters. But we need to talk about the uncertainty. So the first step in talking about the uncertainty is to identify what is the smallest increment that I think that I can distinguish. And so in this case, I'm going to treat the actual physical increment on the ruler, the smallest increment, which is a 1 millimeter increment or 0.1 centimeter increment. So the smallest increment that I can see is 0.1 centimeters or 1 millimeter. Now we need to consider one side of the rectangle that we're measuring. And so with an increment of 0.1 centimeters or 1 millimeter, what that means is that I can distinguish half of that on the one side. So in other words, 1/2 of that increment is the uncertainty associated with the measurement of one side of the rectangle. So there is a plus or minus 0.05 centimeter or plus or minus 0.5 millimeter uncertainty associated with the measurement on the left side and where I position the rectangle on the left side. And there is also an uncertainty of 0.05 centimeters or 0.5 millimeters on the right side. What this means is that since I have to align both sides of the rectangle to the ruler, the net uncertainty is twice that 1/2 increment, meaning the net uncertainty is actually equal to the increment, the original increment. So the net uncertainty would be plus or minus 0.1 centimeters or plus or minus 1 millimeter. And therefore I would read this length from this ruler as either 4.8 plus or minus 0.1 centimeters or 48 plus or minus 1 millimeters. We're now going to consider one more example. And in this example, we have another ruler that is also marked in centimeters. But because of the scale difference, we only see markings every centimeter, but there is quite a bit of space in between each of these markings. So the point of this exercise is, again, we're going to try to measure this red rectangle, and we are going to follow the same steps. But in this case, because these increments, the physical increments of the ruler, are separated by so much more space, I'm going to claim that I can see an increment that's actually smaller than the smallest physical increment on the ruler. In this case, I'm going to say that I can see half of the distance between the marks on the ruler. In other words, my eye can distinguish between 0, 0.5, and 1.0 as an example. So the smallest increment I can see is 0.5 centimeters, which would be 5 millimeters. Just as before, that means that 1/2 of an increment would be half of that distance, or 0.25 centimeters, which is the same as 2.5 millimeters. Now, if this was the uncertainty, that would have to be converted to just a single significant figure, because in our physics class we are saying that uncertainty always has only a single significant figure. But since I have to align both sides of the rectangle that I'm measuring to the ruler, the net uncertainty is double that, and so we get back to a net uncertainty of plus or minus 0.5 centimeters, which is plus or minus 5 millimeters. When I look at this rectangle, I would judge the distance as in the middle between 5 and 6 centimeters. So I would call that 5.5 centimeters, and then I would have an uncertainty of 0.5 centimeters. That'd be equivalent to 55 plus or minus 5 millimeters. The point of the second example is to demonstrate that It is not always the smallest physical increment on a ruler that will determine the uncertainty. If you can see to a smaller increment, then you should use that smaller increment. This is particularly true in some of the later labs this semester when we use this Pivot Interactives website. It will have some built-in rulers, and sometimes the increments are rather large on their built-in rulers, and that you can pretty easily see, let's say, halfway between those increments.